Hi, everybody, and thanks for joining my session. My session is about FinOps success stories, evidences from the trenches. My name is Eran Lador. I'm the lead FinOps at AppsFlyer in the past 3 years. I'm in the field of FinOps for 5.5 years, and I'm super excited to be here. That's my 3rd year in a row in the Israel Cloud Summit. So thanks for having me. I'm kind of giving some context. I will kind of summarize the sessions from last year. So what's the FinOps philosophy and goals that we have at AppsFlyer? So first and foremost, the FinOps is culture. Is culture change towards awareness and ownership change and mindset change, and how to make everyone responsible for their cloud cost. And that's the main key for the FinOps at scale. I mean, you can't do it all by yourself as a FinOps person or team. It takes everyone in the company to make the shift towards FinOps and cloud cost awareness. The second thing is that we want to meet financial targets, and for that we need to optimize costs. And the third thing is that FinOps is kind of good engineering. So it's not the first thing, optimization is not the first thing that drives the company. What drives the company is to innovate, to deliver new features, and to have them stable, to have as less bugs as possible. So we need to find a way to push and prioritize FinOps within these limitations, and obviously to keep simple processes. And as I said, it's part of good engineering. Last year, I spoke about how we changed the mindset from no awareness to cloud cost and FinOps to full awareness. And this is kind of the FinOps adoption framework that we used and we found useful to adopt FinOps. So the first layer is all about getting the data. So taking the CUR and enriching it and having a good, clear, accurate, and relevant data to enrich it with the custom pricing, for example, the company's common language, the company's business logic, and so on. And the second thing is that we want this data to be accessible, to be easy to understand, to be visualized so that people can start to consume it. The third layer is about spreading the word and having the people start to engage with the cloud cost dashboards, to monitor the cost. And tools for this is cost anomaly alerts, and periodical meetings, and so on. The next thing is to define KPI. I mean, what do we measure? And 2 KPIs that we found very useful are budget and the unit economics. And only then the tip of the pyramid is about taking action and optimizing. And as you can see, that's the 5th step. It's not the first one. We didn't start with like right size of a recommendation and stuff like this. So we really wanted to drive culture change. And I'm going to speak here about the optimization part. So what's there to optimize? So commercially, everything you can negotiate from credits and prices and refunds and so on. And financially, it's to optimize the rates, RI, saving plans, capacity planning, upfronts, and so on. These 2 are done by the FinOps team. The infrastructure optimization is a huge layer. For example, right size, waste elimination, auto scale could be for storage lifecycle rules. So basically to use the cloud good in terms of elasticity and scalability. Also, when you optimize your application in code, you can optimize the infrastructure and save money. A lot of the FinOps material and stuff and thing that I saw focus and stop on this layer, which is huge and important, but I'd like to speak where things get interesting. In my point of view, is when there's full utilization, like the infrastructure is working well. And then we're turning into architecture and business layers, which in this case, it requires some trade-off. I mean, you need to compromise something in order to gain something else. And so for architecture is basically which tech components do we want to use, which architectures do we want to use, for example, the database type A or B, multi-AZ or single AZ, real-time versus batch. And for business, this is, in my point of view, this is the crown jewel. We want to understand what drives the cost in terms of business. Is it the incoming traffic, the outgoing traffic? Is it storage? Is it something else? And we want to optimize by this. and to understand what drives the cost, and then price it accordingly or reduce it. And so let's speak about some success stories. Okay, so the first example is about the incoming traffic increase that we saw at AppsFlyer, and I'll give some words about AppsFlyer. So we're a leading company in the world of mobile attribution and marketing analytics. So basically, we get a lot of data on ads, mobile ads, campaigns. It could be clicks if you click on the ad, or impression if you see it. We also receive app activity events. For example, could be app install, app open, in-app event, and then we enrich all this data. And we saw increase in the campaign, in the ads incoming traffic, and it was like full utilization. And it was the increase was going under the radar. And what do I mean by that? Is that everything was working. I mean, we use the cloud, as I said, well, in terms of elasticity and scalability. So when there's incoming more traffic, more cars, for example, we simultaneously have more lanes, more roads, more hardware to handle this. So everything was working fine. Nothing was broken. But obviously it has a lot of cost. So we caught it by the cost monitoring. And this is where it started. And important question to ask, to bear in mind in this area, is what's the business value of this incoming traffic? Does it bring more value to us, to our customers? Does it bring more revenue? Does it bring more customers? And so on. And unfortunately, the answer is not so much. There is a lot of ads, and we don't use them all. So we wanted to optimize this. We wanted to reduce the cost back to the normal. And so at first, there was no prioritization for this project. At the beginning, it was like not an issue. It's just the income. It's seasonality. It will drop soon. But then it continued to grow. And so to optimize it, we got back to the basics, to the pyramid. And the first two blocks, the two layers, is about having the data. So we calculated and extracted the data only for this flow. And we visualized it and monitored it. And the next thing is that we did a forecast. It was part of the annual budget planning. And then we took the cost, we took the growth trend, and we extrapolated the cost for the entire year. And this was the amount, the cost was huge. This was the bill shock for us. And fortunately, it wasn't after we paid the cost. And then the company immediately said, we can't afford ourselves to pay this much for this particular flow. And so we need to optimize it. And soon after, we had a task force. And the task force goals was to reduce the cost. I mean, absolutely nominally reduce the cost, but also improve the efficiency. So to reduce the unit economics. And these foundations and these surroundings are heaven for a task force. It's a great opportunity, great success opportunity. So what did we do? Okay, so we first went to reduce the incoming traffic. So we explored which data we don't read at all or rarely read, and then we contacted the partners and customers, and we mutually agreed to stop sending this data. So we don't need it. There's no value neither for us nor for the customers and partners. And so it's a business optimization. I mean, it's not something that we only did by ourselves. And it immediately, obviously, directly reduced the cost, but it didn't improve the efficiency. So we did some other stuff. For example, in storage, we reduced retention. So we explored and we found that we don't need such an old data. So we deleted it. There is a database, a real-time DB within the real-time flow, which is expensive. And we wanted to reduce the cost of this component. So we reduced the TTL, time to live, which is the storage within the database. So basically we said to the customers, you can't store as much data or as long as you want, we need to cap it. And another thing is that we wanted to reduce the size even more. So reduce the traffic and the storage, but we also wanted to reduce the number of records even more. And so There are certain use cases. We came up with a feature in which we found some use cases that we don't need to handle real time, and we can handle them offline. So we can skip the real-time DB, which was cool. The last thing here is the data freshness. I'm going to talk about this more in the next example. But basically, whenever we could, we reduce the real-timeness without harming the outcome in the business. The results. So basically, within few months, we reduced 50% of the cost back to normal, like before the increase. And we also reduced the unit economics, which basically that's the price for one single data record, which means 25% increase in efficiency. And the next example is about real-time versus batch. So there's two questions to ask here. What's the cost for real-time to handle the data real-time? I mean, like 100 milliseconds or 1 second delay. And what's the cost for 1 minute delay, 1 hour, 1 day? And for each of these, what's the business value? I mean, having data real-time, does it bring more value? Does it bring more customers? Does it bring some competitive edge? So with these two questions, we get going. So there's a few examples for real-time versus batch. So how often do you insert data into database or a data lake? For dashboards, aggregative dashboards, analytical dashboards, how often do we want to fresh them? What's the data freshness for them? And also data export. So we export data to customers, and we want to, and there are large spectrum of possibilities to ship data from real time to not real time, to batch and aggregative. Okay, so what's the project that we worked on? So we use Google BigQuery as a data lake, data warehouse or database. And so we ship data into Google BigQuery for real time, in real time. And for a long time, it was an opportunity task in the backlog to stop shipping data in real time and batch it. And it was reasonably within the business. And we, by this opportunity, we could have saved a lot. But this task for itself didn't get prioritized. It only started to work on only when there was another project, a tech debt project, a project to refactor some of the pipeline to stream data into BigQuery. And we kind of took a ride on this project and like a bit semi-pivoted it from a tech debt project into a saving project. And so what's the effort of such a big project? So as I said, the prioritization and taking the decision was one of the hardest parts, but when the project get going, so the development side of it, so to actually develop the batch pipeline wasn't that time consuming, wasn't that long. And so what took more time is to have the data schema changes. So often when you write a new pipeline, you would need to update the data schema, and we also read from another data sources. And so we had to change the data schema, which was challenging, but that's also an opportunity to clean data that we don't need. And just one tip here, it sounds trivial, but test small when you need to check a new data schema. So do it small, don't like stream the entire data and then check it and then drop it and create new data schema. Okay, so the project management of this project was a bit challenging and complicated. So this pipeline wasn't touched for a long time. And so we didn't really knew who uses each data field, who needs what data freshness, and who are the customers, who are the internal customers, and how we can facilitate all this, and for every phase of the project, remove the blockers and get them to check the data and confirm. So that was challenging. And also the customer communication is also somehow challenging, because when communicating such changes for the customers, focus on the positive side. Don't focus on the SLA degradation, but focus on the positive things, that we optimize the data, we use less data, we ship to you less data, so we optimize your backend also. Less data means better privacy. And to be honest, when we optimize and we are linear, we move faster and we can deliver more products quickly to our customers. Okay, so what's the results for this? So we saw this purple part here is the cost for the real-time data insert. So we saw about 40% decrease from peak and about 19% year-over-year, which is really more because the business grew up during that time, and we had more data coming in. So to sum it up, what's the common lessons that we learned? So first of all, successful FinOps projects are long. It's not about short-term saving, it's long distance running. Prioritization is often one of the hardest parts. So try to write on other projects and try to see how projects can optimize existing things, or new projects, how can they be optimized. And so that's one thing. The projects that do get immediate prioritization are the low big hanging fruits, but fruits doesn't start like this. I mean, the fruit starts small and you need to grow them, and you need to input the cloud cost in every quarterly planning and every design meeting, and also challenge the existing paradigms. Always ask, where can we optimize and how can we do it better? And do you know that this decision would cost us a lot in the cloud cost, and so on. And to finish with the point that I started with is that FinOps is a company-wide culture shift. So everyone at the company has impact on cloud cost, at least for SaaS companies such as AppsFlyer. So everyone should be responsible for their costs, but also aware. And by that I mean also product managers and the C-levels and the customer-facing world. So the last thing is that when you optimize, you save cost, and you also save emissions and pollution and save the planet. So thank you very much. I guess we have some time to answer some questions, and if not, feel free to email me or LinkedIn me.